So zero-point energy and technology. First, we need to understand like the two main physics theory of the last century, meaning the quantum mechanics, first developed by Max Planck and Paul Dirac. It's Max Planck that came up with the concept of the zero-point energy when he was working on the black body radiation and the ultraviolet catastrophe. And what he found is like an electromagnetic field uh, will uh, oscillate, radiate energy even when matter will be at zero Kelvin, or when the field will be at 0 Kelvin. And this creates this very important relationship between energy and the frequency, one half of h nu. And from that, like you can calculate the energy density present in the vacuum, which we call like rho vac, and which is like a very, very large number. And the second big theory from the last century is general relativity, which explain space-time dynamics. So it's Einstein field equations, and you can see this equation presents like as two sides. On the left side, it's the space-time curvature, and on right side is the energy density present in space-time. So if we look at a little bit more closer to this equation, to this result from these two big theory from the last century. So from quantum mechanics, we deduce the zero-point energy, and it says that like everything is always spinning at all scales, and you can see the scales here in the frequency, where there is no limits. It goes like from like a very small scale, and we usually use a cutoff at the Planck length, but it's not really a hard cutoff. And it goes like to the scale of the universe and even beyond. And the other part is telling us that from this fluctuation, we have like an infinite energy available at all time in the vacuum, which is represented by this number when we use the Planck frequency as a natural cutoff to compute the energy, the quantity of the energy density resulting from the electromagnetic fluctuation in the vacuum. And on the other side, we have like this Einstein field equation, which represent the dynamic of space-time, meaning like it's important to understand that space-time is not just a mathematical construct as it can be presented. It's really a medium that flows. And typically, when you are inside a gravitational field, as you are like naturally on Earth, what's happening is that space-time is flowing from up to down to the center of the Earth, and what's put you on the ground is this flowing toward the center of the Earth. And if you look at the equation, it's really like a fluid equation, but in 4D. And the left side is the 4D representation. So the equation is a tensorial equation written in 4 dimensions. And the space-time flow is represented by the 4D surface curvature. So it's kind of like difficult to represent because we are more used to 3D representation, and it's a 4D representation. So curvature is kind of an abstract way to see it. But a good analogy will be like if you look at a vortex inside the water, a vortex will curve the surface of the water, and it's kind of a good analogy to represent the curvature of space-time. But you need to remember that in the case of like Einstein field equation, it's in 4 dimensions, so it's not a 3D analogy. It's like it's just like a very partial representation. And on the right side, you have like the stress energy tensor, which is like basically the energy density that is like curving space-time. And what we did in our last paper and the next one, like the one that will come up like very shortly, we talk about the origin of mass and nature and gravity. And we show how these electromagnetic quantum vacuum fluctuations, which represent like which have like a very large energy density, are in fact the origin of mass and are basically curving space-time. And this curvature in return like represent the mass of the object that we are measuring experimentally. So if we look at the dynamic at the proton scale, what you have is like we define a current region of space at the core of the proton. And in this space, the vacuum fluctuation are current, meaning that they are not like canceling out. In the standard vacuum, you will say like I cannot feel the energy and I cannot measure any energy. And in fact, it's true because like at the Planck scale, the the vacuum is not current, and all the electromagnetic energy is canceling out, so you can't see anything. But in the case in matter, and in particular inside the proton, it appears like the fluctuation are like in current mode, and so the energy density can build up, and it creates a cavity with standing waves and a very high energy density defined by rho vac. So the rho vac that we saw just earlier. So we have like this huge energy density, and from Einstein field equation we can compute the gravitational wave generated by these quantum vacuum fluctuations. And it's what we did. So in this little schematics, we represented like the dynamic of space-time, of the little voxel, Planck-sized voxels that are like dynamically moving inside the cavity forming the proton. So you have like two motion, a poroidal motion and a toroidal motion, creating like the vortex forming the proton. And inside this cavity, the electromagnetic vacuum fluctuation generate gravitational waves. And when we compute like the energy of these gravitational waves, we found out that the resulting energy density inside the proton cavity correspond to the energy density of a black hole. And so we demonstrated like a first result that Nassim showed like 10 years ago, that the proton was in fact a black hole and had a black hole structure, and the Compton radius of the proton was in fact the Schwarzschild solution for the black hole proton, where the black hole mass of the proton result from the conversion of the electromagnetic vacuum fluctuation into gravitational wave inside this current region of space. And from this, like from the black hole proton, we showed that assuming the Hawking radiation emitted by this black hole, we computed the radiated energy from the black hole proton horizon, and we found out that this emitted energy was in reality the rest mass of the proton, so the measured rest mass of the proton. And at the same time, we found that the resulting force from the space-time curvature generated by this gravitational wave inside the proton resonance cavity were corresponding exactly to the color force. So the color force is what they call the force that is like um, keeping together the proton. And they use it with the quarks and the gluon. But in our case, we show that uh, it's only like a gravitational force, so a curvature space-time generated by the energy density inside the proton cavity. So when we saw that, we wanted like to expand the model and to see how it was fitting at various scale. So the first application we made was at the proton scale, and then we tried to apply it at the cosmological scale, the stars and the galaxy, and at the universe scale with the the galactic cluster and the universe. Because we always had in mind that everything in nature has has a fractal structure, meaning that like the structures that you can observe at the microscopic level, you can observe it at the cosmological level. And at all these scales, the same force are, are applied and with the same laws and the same dynamics. It's always the same thing, but with a scaling relationship. So we did like the computation at the universe scale, and we found out like that the universe is a black hole, and it wasn't a new result because in the 70s there were like already papers talking about it. But we redid the calculation with our methodology, and we found out like the same result, and it was extremely precise. So we found out that the critical density of the universe was corresponding to the same screening mechanism that we saw at the proton scale, meaning like that the electromagnetic energy density uh, was screened uh, by the surface of the universe in a similar way that the energy density of the proton black hole was the result of the screening of Rovak by the proton surface. And so we computed the mass of the universe and find the common value, and then we compared this mass or energy of the universe with the total mass that could be like contained in the proton, assuming that the maximum density Rovak was filling the complete volume of the proton. And what we found was like very important and very interesting. And it was like that the energy contained inside one proton was the same energy contained in the whole universe. And this finding is interesting in two ways. First, it was a nice validation of the fractal structure of the universe, showing that like the small scales was built in the exact same way as the bigger scale, but also because it was like reflecting the holographic property of the of the reality, meaning that every piece of the wall was containing all the information of the wall. And it's a very important result that goes with like the other model that we are developing, the space memory network, which says that like instead of space-time, Nassim talk about space memory because the information is encoded, the information, the memory, because we let's define. Let's take just 1 second to define what is time. Time exists only because you have a memory of the past. So it means that fundamentally you need somewhere and you need a mechanism to store the energy, to store the information. Information is energy. To store the information, to have the concept of time to exist. And so uh, what we have in reality is a space memory network where the information is directly encoded in space-time, and every point of space is connected to the other part of the network, to the other point of space-time with a wormhole connection. So it's all described with general relativity. And you have like this network of wormholes that keeps basically the universe in sync with the information shared in all points of the universe at every time. And then like you have like the network of the proton black hole uh, all connected together. And basically, you have a network of black hole at every scale. So you have a network of black hole at the Planck scale, at the proton scale, at the star level, and at the galactic level. Because like there are like black holes at the center of every galaxy, and you have black holes at the center of every sun. So basically, like the proton is the key to understand everything in the universe, both the dynamic of the space-time, which is crucial when you want to build something. You need to understand like precisely and accurately how space-time evolve, move, and so you will be able to engineer it and build on top of it. So what we are working on like currently at the laboratory, it's concentrated on two or three key applications. So energy production, gravity control, and application of the discourse knowledge to biotech. And every time it's like it's applying what we learn at the proton in theoretical physics at the proton level, at the proton scale, to a bigger scale, and reproducing this dynamic into like a device to mimic what nature is naturally doing with the proton, uh, to be able like to extract a motion. And generally like the easiest way is to extract like the motion of the electron, for example, to get an electrical current. And uh, and the step after that, like, it's to control like precisely like code plasma, to spin them in the right configuration to be able like to curve space-time using like very little energy input. So the key idea is to play with the flows, space-time flow, and the direction of it. And what is important to know and to understand from our equation is that gravity and electromagnetism basically are like are emergent phenomena from the same dynamic, which is like the motion of space-time, which we prefer to call like the Planck plasma. And when the Planck plasma is going inward, it's when we call it like gravity. And when it's going outward, it's when we call it like electromagnetism. But it's the same, it's part of the same like the global dynamic. And when you understand that, like you are able like to play to design your device to feed your device with like the right dynamic to be able like to to scale up the motion the, the motion of the Planck plasma up to a macroscopic level where you can like see and measure a usable electrical current, for example. And it's basically that what we saw at the scale of the proton with the black hole mass at the center, the rest mass, and then the electric charge that we can reproduce at the laboratory scale. And then like the end goal is to basically like reproduce the dynamic of a star inside the jar, which will be like just like a spinning plasma uh, in a glass. Okay, I hope I wasn't too long. Let's take some questions from the Q&A. Okay. So, Nama. Alors, let's see if I can bring you up so you can ask your question. Okay, Nama, if you want to. You are on mute.
Hello.
Hello,
Hi, how are you?
good evening. Good, and you?
Very good. Thank you for your presentation. Um, the first question had to do with light and understanding that photons are excitations of the plasma lattice, I believe, if I'm explaining that correctly. So would we then extrapolate that matter itself is a form of light or containment of light?
Yeah, you could say that because like photons are an excitation of an electromagnetic field. The difference is more like that a photon is a propagating electromagnetic wave. And in the case of the proton, for example, it's a resonant cavity. So instead of having like propagating wave and radiation, the rest mass is more radiation, but the core of the proton is like a electromagnetic standing wave because they are like closed inside the cavity. And you
Right.
could compare it like as a laser cavity. But in the case of the proton, like the boundary are like so thick that very little energy can escape it.
Okay. So when we're visualizing the space memory lattice or the excitation and the propagation of a photon,
Yeah.
um, I understand it's all in the same continuum. So at the foundational level, how do we really visualize the propagation of light in the field or through the PSU lattice? Like, how should we really visualize that as opposed to just visualizing it through how we perceive it? How is
So
that? Yeah.
still the photon is a propagating wave, so you can visualize it just with like a string, and if you excite a string, the excitation will move forward. In the case of the photon is an electromagnetic wave, so we know that it's not like in one dimension, it's spiraling, moving. And
Okay.
the analogy with gravity is like is there, like because it's the same with the Earth moving in space. It's spiraling around the sun because the sun is spiraling around the galaxy. So it's like you can see the similarity with the photon. And but the photon, the standard representation, when I represent it like spiraling, it's like the direction of the electric field that is spiraling. So it's in the classical representation, it's like the spiraling is representing the polarization of the medium, so of space-time.
Okay. Thank you for that.
Thank you.
I appreciate that. I did have two questions, but I didn't know if you wanted me to ask the second one.
Yeah, yeah,
We
sure.
can move
As the
on.
second one, yeah,
It
about
had
the
to do with
possibilities. Yeah,
the vector equilibrium in the kernel 64.
yeah.
And is it that symmetry itself that replicates and scales, but may become out of phase as it leaves the Bose-Einstein condensate? Is it still the same symmetry we're dealing with, or how would we characterize
There
that?
is a breaking of symmetry because, like, when you have like the 64 and the vector equilibrium, you are in the state, the more coherent state. So you have the more energy density, the highest energy density, we could say.
Mhm.
Uh, and then when you and it's a black hole. The kernel 64, when you do the math, it's exactly a black hole. But when you scale up, you change the relationship between like the of information inside the volume and those at the surface. When you take the 64, the kernel 64, you have like 64 units in the volume and 64 units at the surface. So you have a 1-1 ratio for the information exchange. So you have no tension and all the information inside can communicate with the outside. But when you scale up the black hole, for example, at the proton scale, you have like a huge discrepancy between the energy that is inside and the energy at the surface. You have like 10 to the 20 difference when you do the ratio. And that's what Nassim called the orographic ratio. This discrepancy between the information inside and the information that is available to the outside. So you have this, you could say like surface tension. You have like this huge pressure, this huge amount of information contained in the volume, and only a fraction of it can escape, can be transferred to the outside through the surface. And so this tension creates the wall dynamic and the structure with the double torus structure of the proton, so
Uh,
of matter. And it generates what we call gravity and electromagnetism.
okay, so that discrepancy creates that pressure gradient, and
Yes,
okay,
the
and
discrepancy of energy or information between the interior and the surface.
okay, so and thank you for that. This will be my final thing. So when we say that it's the Schwarzschild or a black hole, it's mainly we're measuring the 64 as the black hole mass.
You have black hole at every scale. So the
Okay,
64 is the first black hole, the smallest black hole,
okay,
because it has only like a radius of 2 Planck lengths. And then like you have black hole at the size of the proton, at the size of the star, and the universe is a black hole.
got it. Okay, thank you so much for that. You clarified a lot. Appreciate it.
Thank you. Let's have like the following question. Hélène Lajoie. Let's see if she's available.
Hi, can you hear me?
Yes, perfectly.
Yeah, I had two questions. One was about you mentioned 4D space time,
Yeah.
and the other question, it kind of tacks on to what Nama had asked about gravity versus E and M, and that's it. So both those are created out of the pressure between the inside and the outside of that proton. Is that correct?
Yeah, a proton or like at every scale. So yeah, at the proton, but
Okay.
also yeah. So basically, like the 4D spacetime is saying like as you write in your question that there is like two dimension of space and one dimension of time. You had like Kaluza-Klein theory, so other theory like adding a fifth dimension for the rotation for the spin. But in the standard Einstein field equation, you only have four dimension. The spin is removed, so yeah, it
Of
it
course.
kind of like complicated a little bit the things. It missed part of the picture, so let's say that.
But you're
And
still
yeah,
you'd still be using spherical coordinates for your equations, though, right? And,
in a in 4D and in tensor equation, like we use like metric coordinates, which is
oh,
kind of like different than spherical coordinates. Spherical coordinates are like just for 3D,
okay.
like they are like more useful with Euclidean plane and 3D representation. But when you are in space-time, you need like so in four dimension, you need to use a tensor and a matrix coordinate. So the most known metric coordinate, which are like in fact to be more precise, they are like solution to Einstein field equation, and you have like multiple solution for Einstein field equation. The most known is the Churchill solution with the Church and even in this case, like you have different set of coordinates that you could use with the Churchill condition, the Churchill solution. But it's very mathematical, very technical. So
Okay.
do you have like a more precise question or
Oh no, no, not on that one. It was I was interested in how do you add the extra space dimension to your, but yeah, if you're using the tensors, that makes sense. Could you repeat one more time so I have a better physical picture in my mind? So gravity is from uh, the torus spinning one way, and E and M is from the torus spinning the other way. Can you elaborate?
uh, no, if you say that, it will be more the distinction between particle and antiparticle. Uh, for gravity and electromagnetism, it's more like gravity is um, is the flow from outward to inward, so the flow in, and electromagnetism will be the flow out. If
Okay.
you have like a mechanical representation,
Okay. Cool. Thank
and
you.
both like gravity and when you write it like in a vectorial representation, like Newtonian representation, yeah, you can see it as a flow in and yeah, like the
Okay.
Planck plasma, the voxel of space-time are flowing like a flow, like a fluid. But it's tricky because all matter is made from this particle, this dynamic. So basically, the proton is a little vortex ring floating inside um, inside the vacuum, inside this huge sea, this huge ocean, with like an additional motion on top of it,
Hmm.
which we call like gravity, gravitational field.
And so when you say for in your technology that you've replicated the effects of the photon, then are you seeing both the gravity effect and an E and M effect?
Yeah. And when we try to when we focus on energy extraction, we focus more on the electromagnetic effect because the goal is to extract like the energy of the electromagnetic field because
Mm.
electricity is what we currently use for our devices. And when we want to control the gravity, it's more like creating local creating curving locally space-time to have like a gravitational effect.
Cool. So no levitation quite yet?
Quite yeah. Not with that we can communicate on, but yeah, we are working toward that, and we have like the principle and the technological roadmap to reach it. But yeah, right now
Wow.
we can't show anything.
Great. Thanks so much.
Thank you for the questions. So let's take the next question. Marco, let's bring Marco. Marco, you want to ask a
Hello,
question? Hello, Marco.
hola, hello, hello everyone. And first, sorry, my English, I'm not from the physicist background, and I come from linguistics and literature, philosophy. But been following Nassim since 2010. And well, my question was about something Nassim mentioned in a past Q&A,
Mhm.
and was that the description for the Planck oscillators, it was the Pythagorean triangle, rectal triangle. So I was very interested in grasping more about that description, and I was asking if there is somewhere where we can learn more about it. And of course, I'm taking you for
Okay.
that for the job now. If there is something you can bring to the table about that,
Okay.
it's very
Yeah. No, it's clear.
yes.
Okay.
Sorry.
So when Nassim mentioned the Pythagorean triangle, is to remember the relationship discovered by Einstein. It's the energy momentum relationship, and it's called like the Einstein triangle because it's an easy way to represent the relationship between energy, momentum, and mass. And basically, it's the more complete version of E equal mc square because and it's called the energy momentum relationship. So it's not general relativity, it's special relativity, and it's about how mass change when it's in motion. So it's the triangle is represent this relationship between mass, momentum, and total energy of the system.
Yes, and if there and there is there a reason for it to be a rectangle, the relationship, and not
Uh,
another triangle, and not another an equilateral triangle, another kind of triangle? I know it's very geometric, but that's my kind of feel or
when
yeah
when you look at
question.
the relationship, it's an equality between square, and so it's like it's naturally looking at the Pythagorean relationship with a triangle. When you have like the
Because of
square
square.
of the sides equal the square of the hypotenuse. So that's why like it was associated with the
rectal triangle.
Yes, rectangle, triangle. Yeah,
Okay,
exactly.
that's fair. Thank you very much,
You're welcome. Thank
and
you for the question.
congratulations for all the work.
Thank you. Let's take next question. Next question is from Bob. Let's see, Bob.
Hey.
Hi, Bob.
Hi there. So I have a very simple question.
Yeah.
If you operate a star in a jar on the surface of the Earth and you extract energy, do you change the local Newton's small g? Do you change gravity?
It's locally, it's the goal. Like if you, the goal of controlling gravity is to like to levitate from the ground. So locally, you will change the small g, and you will float. That's the main goal. But it will be just like locally, like you won't change the mass of the Earth or like the gravitational field of the Earth. It's just like you create locally a kind of gravitational bubble because you will modify locally the curvature of space-time. Basically, you want a flat space-time so you can float.
Yeah.
So you compensate the acceleration, and you can see it like a fluid dynamic also. Like you have a flow which is represented by the small g going inward, and you want to create the opposite flow upward. So you create an upward torus like that will compensate the flow going inward toward the Earth, and you float. So the theory is simple. The technological part is more tricky because you need to scale up the flow because we are talking a Planck scale flow of the space-time. So you need like to scale it up uh, to have a macroscopic effect.
So my follow-up to that is, what happens at a Lagrange point where space-time is flat?
Yeah, but the Lagrange point, yeah, it will be similar. The Lagrange point for the others that doesn't know what it is, it's like the point between planets or between the Earth and the Sun, or between the Earth and the Moon. So between like two gravitational fields, you have a point where all the forces cancel out. So you could say like we will create a local Lagrange point to float in space.
So can you extract energy at a Lagrange point?
Um, it wouldn't be the easiest way to do it because it's easier like to directly manipulate the electromagnetic field uh, instead of like using the gravity. But um, I need to see, yeah. Maybe it's not the first way we are looking at it for extracting energy because like there are like way simpler way because the first step is like extracting energy because it's the easier way, and then like creating a gravitational wave and controlling gravity is the second step because it's more difficult.
I'm really not suggesting doing it. I'm really just trying to understand get a mental picture of how this works by considering a couple of test cases.
Oh, okay. Yeah, so how it works, I think like the easiest way to represent it is like visualizing space-time as a flow. And so it's more complex because it's in 4 dimensions, etc. But it's a very good approximation to see it as a flow. So as a flow, a pressure, an acceleration. And so if you want to resist the flow, you need to create a flow in the other direction. And you have like waves, different way to do that when you understand the equation. But when you look at the equation of gravity, the linearized one in weak field approximation, they are like in a lot of points, they are like the same as the electromagnetic equation. So very similar to the Maxwell equation.
So I have one more question further down the chat, but it follows perfectly from what you just said. So I'll ask it anyway, and if you want to answer it, that would be great. If charge is an outward flow, what is the sign of charge?
So the sign of charge is more like the direction of the spin, the motion, because you have the double torus dynamic. So you need the way to visualize the torus is like you have the flow out, it goes to the pole, and the flow in, and it's what's called gravity. And it's a simplification because we know like the gravity goes from all direction, but it's a simplification to visualize it. So you have like this poloidal motion, and then you have like the toroidal motion.
Mm-hmm.
And it's the toroidal motion that will polarize the vacuum in one direction or in the other direction. That's why like you have like the proton that will spin in one direction and will be charged positively, and the electron spinning in the other direction will be charged negatively. And and then like you have like a kind of conservation of angular momentum, because you know like one thing that is very important to conserve is the angular momentum, which is difficult to understand and not that intuitive, and because you can see all the nice experiment you can do with a gyroscope and testing how the conservation of the angular momentum is working, and can be like a little bit tricky to understand it, to understand the the motion of a gyroscope.
Thank you very much. I could probably come up with about half a dozen more questions, but thank you. You're wonderful. I appreciate your explanations.
Thank you, Bob. Thank you for the question. So let's take another question. Thank Elisabeth. Elisabeth.
Bonjour Olivier.
Bonjour, bonsoir.
Bonsoir. First, thank you very much for the presentation. It's really, really interesting. And I'm not a scientist, so it's difficult for me to go in depth in the details, but it's a question I would like to ask is how easy could it be to switch the form from wave to confined, so from the photon to proton back and forth? I think, in fact, with the explanations you've given before to the other questions, you probably are close to answering my own question, but could you add something on that?
Yeah, it's a very good question, because like it's not intuitive like to understand why like we are saying like there is like the same energy everywhere in space, in the vacuum, everywhere. And yet like you can feel that there is like space that is different, that is more rigid than the rest of the space. And the only difference is the currency of the waves. Like in the vacuum, where there is no matter. The electromagnetic waves are like non-coherent, so they are like fluctuating, but not in sync. They are not synchronized. So one is up, the other one is down. So the average value of the energy density is 0. But when you have matter, what you saw is like there is like it's forming a resonant cavity, and the waves start like sinking, and this sinking process is a natural process that you can see like everywhere in nature, and you can even like do it at home like very easily if you have like metronome. If you play music, you 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 will have one, or you need at least 2 or 3 metronome to see the effect. But you have like a video on YouTube like showing that, and it's very interesting because you can demonstrate that as soon as you have like a weak coupling between oscillators, and metronomes are like a good example of oscillators. When you have a weak coupling between oscillators, after like a very short period of time, you will see that all the oscillators will come in sync. And you have some videos on internet like that, like very interesting, because they show like a large array of these metronome, and they start all the metronome out of sync. And just like by putting all the metronome on the same plate, on the same table, and allowing the table to move just a little bit, uh, and this motion of the table is representing the weak coupling between all the metronomes. But the metronomes are not like directly attached. They are just like on the same surface. And you will see after like a couple of seconds that all the metronomes start being in sync. So same frequency, out of phase at the beginning of the experiment, and after like a couple of seconds, they will be all in sync. It's like it's surprising the first time you will see it. And what we need to understand, and what we understood, is like space-time is acting the same way. Like you have like this teeny oscillator, the kernel 64, the voxel, the elementary voxel of space-time. They are like small oscillators, and in the vacuum where there is no matter, basically these small oscillators, they are not like spring, they are not like metronomes, they are oscillators, so they are like spinning, because everything is spinning. Everything around you is spinning, like from the Planck scale to the atoms to the planets, stars, galaxy, everything is spinning. So you have these little oscillators, and usually they are not like in phase. And but when you create a resonant cavity, and there are like various ways to create resonance cavity. But when you create a resonance cavity, you have like standing waves appearing inside it, inside the cavity, and it's the same ways that you create, like for example, laser light. You have a resonant cavity, like uh, pumping electron, I mean pumping photons at the same frequency and in phase, so synchronized. And then like you have the laser, a very powerful photon emission, and so it's kind of similar in the way that you have like this resonant cavity, and you start building up energy because everything gets in sync. So and to come up to the proton, you need to have like this gravitational effect. You need to create to have mass to appear, and it comes naturally, as we shown like from computation from Einstein field equation, that when you build up an energy density in space, you start curving it, and when you curve space, it's what we call mass. You can simply see it like that. So how, yeah.
Yeah. And how does it play with the human biology? In fact, how can I
It's
apply this? to human biology?
It's a good question. It's part of the presentation that William and Nassim are like currently doing like tomorrow
I'd like to be there.
in Barcelona. Yeah, in
Like,
Barcelona they are having like the conference on consciousness, and it's a nice conference because like finally physicists start talking openly about consciousness, so how physics and biology works together to make conscious being to make life. So it's a very good question. Maybe I will let William answer it next Q&A in next month. Yeah, because like yeah, it will be like too short. But yeah, it's the same idea. You have a scaling law, and you scale the same mechanism. You scale it, and it's very interesting because when you look at a neuron network, so neurons in the human body, it has the same shape and the same properties as the galactic cluster network. And when you look at the picture, you see, oh, it's the same, and it's the same mechanism behind it.
okay. Thank you. Thank you, Olivier.
Thank you for the question. So last question. Let's see. Martin. Let's see. Alors, Martin. Yes. Hello, Martin.
Oh, hello. I didn't notice. Can you hear me okay? Sorry.
Yeah. You were mute.
I was just hoping that you can have a read since I'm not a physicist and it's pretty complicated stuff. I'm basically thinking about the way how planet Earth is moving through cosmos in relation to the sun and to the galaxy. Something like, cosmic journey kind of stuff. I'm trying to build this modeling, solar system with the donuts. But like I said, I'm not a physicist, so I'm sorry about that. And my question basically is about any suggestions, if you can think of anything regarding understanding the way how Earth is moving along with the sun through the cosmos. Thank you.
So you have, yeah, you need to consider like different scale. So you have the motion of the Earth and of the Sun inside the galaxy, and now you have like nice animation. Nassim made one 30 years ago, but now you have more modern one, and you can see like the Earth spiraling around the Sun, and the Sun moving around the galactic center.
Oh
So
yeah,
you have
I
this
mean,
spiral motion, and then you have the the torus, and also like you have very good. It's not like it's representation because like it's not like direct photography, but if you look at the representation of the Oort cloud, so it's the solar system, but well beyond the Pluto, well beyond the last planet with all the meteorite, etc. And it represents nicely the complete gravitational dynamic of the solar system, and you can see it like literally forming the double torus shape. Same with the galaxy. You have like some nice picture of galaxy like showing the double torus. It's tricky for the galaxy because some you saw them like from different angles, so the double torus is not always like easy to see. But you can see it at the galactic level. You can see it at the solar scale. You need to Google like Oort cloud, and you will see the shape.
I mean, uh, from a simple perspective, it's pretty easy to understand the fractal nesting of the donuts of Earth, electromagnetic field, sun, and galaxy, and all of those others. It's just that I'm not sure how to connect this fractality together, since the nesting is not like centered, it's somehow along the lines of dynamics that could be, I think, understood simply as lines. It's just that we need to have more information about every single one, and I'm just missing this kind of deeper explanation of the dynamics that could be, I think, explained by some sacred geometry. Thank you.
Yeah, look at fractal geometry, because you need to consider the when you look at through scales, especially if you look at like from the Earth, galactic, universe scale, you are moving like through like different scale, and the relationship is like it's all about fractal. So there is no one center of you are never at the center at the same time. You are always at the center, and it's a mathematical property of fractals. When you look at fractals, but it's difficult because the mathematics behind fractal is not that simple, and it wasn't like applied yet to cosmology and to physics in general. But you will have the main concept, the fractal structure. I'm not sure. I don't know if you are like familiar with the fractal, but when you zoom in or zoom out, you will always find the same geometry. Maybe not at the center where you are, but like just nearby, but you will always have the same geometry, the same motif.
Can I comment on that, or we haven't got time?
Yeah. You have a few minutes, yeah.
I mean, the fractal idea is known to me. It's just that I can imagine electromagnetic field of Earth like a donut, and then we have one with the sun, and then we have one with a galaxy. But the way how the Earth moves through space is pretty dynamic, and it's hard to kind of describe simply, since it's all of those gyro kind of movements around. I think still not really well explained, but somehow like self-orientation within this space would be nice to have, if we will have that kind of update on the way how that kind of movement could be felt. And I think it translates basically to the fact that we into the way how consciousness expands in all direction and inside out in same time. So the way the movement is understood. But yeah, I'm more like an artist, not a scientist.
So yeah, you are moving like many pieces at the same time. One thing, so for the motion, one thing that could help you, like if you look at like the dynamic of vortex ring, it will show you like how the angular momentum is conserved and how it's crucial for the stability of the motion through time and space. And the other part, like it will be more like about the space memory network and how the information is shared between every point at every time, every point of the universe at every time. So everything is always synchronized, and every point has the information of the world system at every time.
Thank you.
Yeah. So if I can't develop more, but yeah, it was a very good question.
Do you have any books maybe you can suggest on that, since it's something that it's not really well explained, although that idea is bouncing around from here and there, but again, not very well explained.
Nassim is working on a book. It will be like published soon, and there will be like yeah, a good part of the answer you are looking for. Yeah, because he's talking about the dynamic of the cosmos and how it's related to the value scale. So you will find the answer about that. And about other books, like I don't have like other books detailing what you are talking, because you are mixing like different concept, and usually they don't mix all these concepts in the same book. Yeah, but yeah, it's a very good question.
Thank you.
Continue your study, like it's a good path. Okay. Thank you, everyone, for all the questions and being there. It was a pleasure discussing with you, and we'll see you like in few months. Next month, it will be like I said, William, but maybe it will be more Cyprien and William in September to respond all the question about like biology and what they did like at the Barcelona conference. It's quite interesting. Like it's actually right now. It's this week. Okay. Have a great week, everyone. Great evening. Bye.